right, hi everyone. Today we're going to work on just adding and subtracting radical expressions. So this shouldn't be too bad. We just have some thoughts we have to get together about what exactly does it mean to be a like radical. All right, so let's define that. So when we say like radicals, we talked a little bit about this when we did multiplying and dividing the other day. They have to have the same index or the same root. So things that have the same index slash root. Okay, so cube roots with cube roots, fourth roots with fourth roots, square roots with square roots. So you can't add or subtract like square root of 5 with the cube root of 3. That's just not going to work. But they also have to have the same radicand. Now, if you remember, we defined radicand as the number underneath the radical. So, for example, things like the cube root of 2x and the cube root, 7 cube roots of 2x are like radicals. But something like the square root of 3y and the square root of 7x are not like radicals. So these are not like radicals. Okay, they may have the same root, but they don't have the same radicand. So we want to make sure it has to meet both criteria before we can start working with it. All right, so if we're going to combine or add and subtract radicals, the criteria is, again, they have to be alike, same index, same root, same radicand, or else we can't do it. But when we're adding, we're going to want to think of these almost like adding and subtracting variables, kind of like we're going to add the coefficients. So if it's like, let's say it's a square root of x plus b square root of x. So the idea is kind of like we're going to add a and b and leave the square root of x. Okay? So for example, if I had, shall we say, 6 square roots of 2 plus 2 square roots of 2, it's like going 6 plus 2, and we're going to leave the square root of 2, and we're going to get 8 square roots of 2. Okay, now most of us can see that we're just going to add the 6 and the 2, carry the square root of 2 with us. But I want to make sure we're clear on why we're adding the coefficients and not touching the radicals. And we're going to do the same with subtraction. So if I keep that same notation, a square roots of x minus b square roots of x, we're going to get a minus b square root of x, and that's where we're going to have it. Okay, subtracting the numbers or the coefficients in front. So if I use that same example, 6 square roots of 2 minus 2 square roots of 2, 6 minus 2 goes together. We're going to keep that square root of x, and we're going to get 4 square roots of x. All right, so let's try a couple of problems. Now, we may need to simplify first before we add and subtract. So let's make note of that. That simplifying first may be something that we need to happen. Because we may need to simplify so that we can find if the radicals are the same or not. So we may have to do some simplifying while we're trying to do this. All right, so let's take a look at the first one. All right, so are they like radicals? They're both 3's and they're both square roots. So the answer is yes. So we're going to add the numbers in front. So think of it as 9 plus 2. And we're going to keep that square root of 3. So we get 11 square roots of 3. I was subtracting. Okay. All right, let's try this one. They're both square roots, but one's the square root of 2 and the other is the square root of 3. There's nothing we can do here. This has already been simplified. Okay, we can't do anything with it. We can't add it. We can't subtract it. We can't do anything else. All right, so let's try this guy. All right, we have 8 cube roots of 2x and 2 cube roots of x. Are they the same root? Yes. Do they have the same radicand? Yes. So then we're just going to add the numbers in front, and we get 10 cube roots of x. All right, so let's try something a little harder. Oh, no, it's still the same. Okay, so -1 fourth root of 12x. All right, so we probably, we can't do anything with that fourth root. So let's come down here to number 5. All right, so we do have the same root, but they are not the same radicand. So we're going to have to take both numbers, simplify them down, and see if we get the same radicand. So let's take 125, break him down. Again, this is square root, so we're going to simplify. We're going to use our pair. Okay, so we get the square root of 25, square root of 5, or 5 square roots of 5. Okay, now we're going to take 20, 4 and 5, 2 and 2. Okay, so 20, we still have that 2 out in front. Square root of 4, square root of 5. So minus 2 times 2 for the square root of 4, square root of 5. So this becomes 5 square roots of 5 minus 4 square roots of 5, which just gives us 1 square roots of 5, or just the square root of 5. All right, let's try one more. Now again, we can simplify with variables involved as well, so keep that in mind as you try tonight's work. All right, so let's do cube root of 81. Notice they're all cube roots, so we may be able to simplify this, but we do have to simplify all of our numbers first. So we do have a lot of scratch work to do on the side. All right, so 81, and we are looking for cube roots. So 9 and 3, 3 and, oh, sorry, not 9 and 3, 9 and 9. Okay, 3 and 3, so we need a group of 3. There it is. So this will be 4 cube root of 27, cube root of 3, or 4 times 3, cube roots of 3, or 12 cube root of 3. Okay, so now we have to do 72. And again, we're looking for a group of 3. So 72, I'm going to use 9 and 8. Here's my group of 3, and these guys right here is a pair that I'm going to multiply together. Okay. All right, so we get plus 2 cube root of 8 cube root of 9. All right, if you need to use parentheses just to distinguish between them, feel free. Okay, this guy's getting in the way, so I'll move him up there. All right, so we get plus 2 times 2 cube root of 9, or plus 4 cube roots of 9. Well, the way it's looking right now, it doesn't seem like these guys are going to be able to be added or subtracted. So let's see what we can do with 24. All right, so 24... I'm going to do 3 and 8. Okay, so here's our group of 3. Okay, so minus 3 cube roots of 8, cube root of 3. So minus 3 times 2, cube root of 3, minus 6 cube roots of 3. All right, so it looks like we're going to be able to combine 2 out of these 3 terms, the 12 square roots of 3 and minus 6 square roots of 3. So our final answer would be 6 cube roots of 3 plus 4 cube root of 9. Okay. All right, so that's it for today, short lesson. Let me know if you have any questions. Stay safe, guys. Please be careful out there, and stay in so you and your family can be safe.